MS Ramaya University of Applied Sciences.
Hello students, today we will be studying about the generation of 10 kHz square wave using timer 0 in mode 2. The main application of timer in 8051 is generation of waveforms and to provide the time delay. There are two timers in microcontroller, namely timer 0 and timer 1. To select the timer 0 in mode 2, the T mod register should be set to 00000010. Now let us see what is meant by this T mod register, how to set this T mod register to get the timer 0 in mode 2. So T mod register is nothing but the timer mode control register. So the timer mode control register is an 8-bit register which consists of bit 0 to bit 7. The first 4 bits, that is bit 0 to bit 3, are reserved for timer 0 and bit 4 to bit 7 are reserved for timer 1. Since we are not using this timer 1, the 4 bits, that is bit 4 to bit 7, are made to be 0. Then we are using timer 0, so these 4 bits should be set. Let us see the significance of these 4 bits first. So the gate bit is set to be 0 here, because if the gate bit is set to be 0, it means that it is software controlled. That is, the timer program, whatever we are doing, that is software control here. That's why the gate bit is taken to be 0. Suppose if it is 1, it means that it is hardware controlled. Then C or T bar, which means that if this bit is made 1, it acts like a counter. If this bit is made 0, it acts like a timer. So we are using in timer mode, that is why this bit is taken to be 0. Then comes M1 and M0. So you can see the table here, M1, M0 and mode. In order to set the mode 2, we need to select the M1 and M0 bit to be 10. Therefore, we set this M1 and M0 bit to be 10. Hence, we obtain the T mod register value to be 00000010. Next comes some of the calculations which are involved in this program. The calculations which are involved in this program are to find out the time delay and to find out the initial count value. In order to find out the time delay, the given data is frequency. Frequency is 10 kHz. So the time is nothing but inverse of frequency. When we substitute the frequency value, we obtain the time delay to be 100 microseconds. Here we are generating a square wave, as you can see in this figure. So the T on time, that is the time period during which the square wave is high, so that will be T on and the rest of the time will be T off. Since it is a square wave, we get the T on time equal to T off time, which is 50 microseconds. Then comes the calculation of initial count value, which needs to be loaded into TH register. So initial count value can be found out by using the formula initial count minus 1 equal to maximum count value in mode 2 minus time delay into crystal frequency divided by 12. We know that maximum count value in mode 2 is 00FF and the time delay is calculated, that is 50 microseconds, and crystal frequency is known, which is 11.0592 megahertz. When you substitute all these, we obtain the value to be 209.92. When we convert it into hexadecimal value, we get the value to be D2. So this D2 value needs to be loaded into TH register while doing the programming. After the calculations are done, click on the Keel Microvision 4 software. Whatever may be the program before, go to project, close project. So there are two main steps which are involved in programming the square wave using Keel Microvision 4. First one is to create the project. Next is to create the file and then add that file to this project. Now let us create the project. Click on project, new microvision project. Let us go to desktop, new folder let us create by name microcontroller. In this let us add the program square wave generation. So this is the project name. Give save. Once this is done, let us select the microcontroller, which microcontroller we want to use. Since we are studying Intel 8051 microcontroller, I am selecting Intel company, that is 8051 EAH. You can see the specifications of the 8051 microcontroller towards the right. Then click on OK. Once you click on OK, it will ask for the project folder and add the file to the project, that is startup file needs to be added or not, it is asking. It is not required, so give no. Once this is done, go to file, new. So in this editor window we need to write the programming. Since I have already written the program and copied it, let me paste the program here. Once this is done, now go to file, give save as, then give the file name as square program dot asm. You can give any name for the file, but the extension should be .asm for the file. So click on OK, save. Once this is done, now right click on the source group, add the existing file to the folder, then click on ASM. So you will get square program.asm is our program. Give add, close. Once this is done, you can click on this plus mark so that this program is being added into your project. So how will you check whether it is added or not? So close this, again double click on this so that if you get this again, so it is said that your file has been added into your project. Once this is done, we need to give build target. Once you give build target, it checks for all the errors and warnings. If there are any errors, it will show. So since there are 0 errors, let us go to debug, start debug. Give OK here. Close this window. Once this is done, since we want to see the square wave generation, let us go to logic analyzer. Before looking into the square wave generation, let us see the program, what it means. So the first step means that org0000h means that the origin or the starting address is from 0000h. So we are considering a port pin, that is port 2 pin number 3 is considered and it is made logic low, and tmod register is loaded with 0 to h. That is how we have explained in the PPT, and move th0, 0 d2h, that is d2 has to be loaded into th register. In the calculations we have seen how to calculate the value of th register. Then give set btr1. So set btr1 represents that timer run bit is set, so timer is being started. Then jump no bit tf1 to l1. So till it becomes no bit, the timer flag will be keeps on looping over here, that is it keeps on looping over here. Once this 50 microseconds is over, it comes to clear TF1 so that the timer will be stopped and complement P2.3. So P2.3 was initially low, now it becomes high. Then S jump to L1, again it comes to L1 and this keeps on repeating. So this program is being executed. So we need to give the pin P2.3 here, P2.3, give close. Once this is given, give run. So zoom in and zoom out, you can see the square wave which is being generated. Thank you.
At MSR UAS, we spark your imagination unlike any other.